Alright guys, so welcome back. We've got more examples here on differential of calculus where we are taking the first derivative. If you have seen the previous video, I have given you the steps on how to solve these equations. You must make sure that everything is simplified, and also you must ensure that you don't have fractions and everything is in a linear format before you can start to take the derivative by definition, which is given by this. If you've got f of x here is equals to x to the power of n, you must drop the n and then you must say x minus 1 from that n that you have dropped. So if you look at this question here, which is question number 1, is given by f of x is equals to 5x to the power of 4 minus x cubed plus 2x. It is in a linear form and then there's no fraction, therefore we are ready to take the derivative, right? So you'll come here and say f of x prime, which is derivative number 1, is going to be equals to 5, and then you drop the n, which is 4 in this case, which is equals to 4. X therefore is going to be 4 minus 1, and then you go ahead on the next one, you drop the n, which is 3, then you're gonna say x 3 minus 1, and therefore here in this case on the last term we have got 2 there, and then you're gonna drop the 1, then you're gonna say x to the power of 1, because this means that is x to the power of 1 here, then you're gonna say minus 1. So therefore we can simplify this. This will give us 5 times 4 is going to give us 20, x to the power of 3, 4 minus 1 gives us 3 there. Here what you're going to have, you're going to have 3, you're going to have 3 as it is here, then it's going to be x, 3 minus 1 is going to give us 2, therefore here what you're going to have 2, which gives us x to the power of 0. So you would know from the exponent that anything to the power of 0, it is equals to 1. So therefore you're gonna come here and say x 20 x cubed minus 3x squared x squared. Therefore what you're gonna have here, you're gonna have 2, because anything to the power of 0 is equal to 1. However guys, I want to indicate something here that you are going to be able to use when you do a cubic function. They might ask you to find, I'm just putting it here for an example, they must say to you, find the second differential. Okay, if they ask you to find the second differential, because now this is the first differential, so the second differential you will have to take the differential of a differential, which is the derivative of a derivative. So now you're gonna come here, this is what we have now. This is one of the concepts that I remember that on the previous example we left this one out. So I'm just gonna get edit here for the sake of understanding. So if they ask us to take the second derivative, this is what we're going to do. We're going to say f second derivative is equal to, therefore here is going to be 3, sorry, we have a 20 there, then you drop the n, which is 3, is gonna be multiplied by 3, and then it's gonna be x cubed minus 1. Similar thing would apply here, 3, you drop the n, which is 2 in this case, which is going to be 2 minus 1, and plus here the derivative of a constant is 0. So therefore this would be our second derivative guys. So this is allowed, you will see as we go further, or if you watch more examples, go to the playlist, you will see that here on this channel we do have a situation where we are dealing with a cubic function. If you are here new on this channel, I am Gaston Mapala, passionate about mathematics, and then also engineer by profession, vets, honors BSc graduate, and then University of Northwest postgraduate, UP graduate as well. So I just thought that since I'm passionate about mathematics, I should open this channel and share with you guys so that you are able to get distinctions in your matric, grade 10 and grade 11 the same way I did. Right, so thank you. Please share this video with others and make sure that we all get to level 6. Right, so we're gonna be left with this. So this will be our second differential. Right, Okay, so if you've got a question, please let me know on the comment section below, or if this video really helps you a lot, give us a like, and then so that YouTube can recommend this video to many other learners. Right, so let's move on. Here we have got this one here. As you can see, our equation is not in linear format, so first thing first, we're gonna have to simplify this. So what we have here, we have got 8 x to the power of half. What we can do here, we need to divide everything by 2x cubed, because we want to simplify this and make sure that we don't have a fraction thereof. Okay, so now this one, 8 divided by 2 will give us 4, and then what you have here, you've got x 1 over 2 minus 3, which is our exponent there, because now if the bases are the same, you remember from the exponent, these bases are x and x are the same, and we are dividing, therefore we would minus the exponent, which is basically what I just did there. And then 4 divided by 2 will give us 2, and then if we take this x cubed to the top, is supposed to have a negative there. Right, so now the only thing that we need to do there is to simplify that to half minus 3. We need to simplify that half minus 3. How are we going to simplify that? Half minus 3 is going to give us, guys, you don't have to worry about this, you can punch it into your calculator, x to the power of negative half of 5 over 2 rather, then you've got plus 2x minus 3. So therefore this is our equation now. Is it in a linear form? Yes, it's in a linear form. Can we simplify it further? No, we can't. So we are ready to take the derivative now. Okay, let's come here and say, okay, therefore f of x prime, which is our first derivative, is going to be 4. Then you drop the n, which in this case is negative 5 over 2. Therefore x minus 5 over 2. Therefore minus 1. Okay, and then therefore as we continue here, we're going to have plus 2, drop the n is what, negative 3. Therefore x minus 3, then we minus 1 there. The only thing that is left here is for us to simplify this, and that would cancel out. Then we're left with 2, which is going to give us negative 10 x to the power of how much? Okay, now I'm just gonna go to my calculator here and then simplify this. This will give us negative 7 all over 2. Then here we're gonna have negative 6 x to the power of negative 4. Okay, so most of the learners will ask, if you leave it like this here, is it fine? Yes, of course it's fine. You should be able to get full marks if you leave it right there. And that's how you take the derivative, guys. The pattern is always the same. You start by simplifying if you've got fractions, because you want your equation to be in a linear form, so that it's easy for you to take the derivative. So please, you can't take the derivative when your equation is like this. Right, so let's move on. Interesting one here, which is going to be our last question for this video. But if you want to see more videos, please watch until the end, where you will see a link that will link you to other calculus questions, like such as first principle, cubic function, you name them, everything that is required for you to do on calculus in grade 12. Right, so it says here that if y is equals to 4x squared minus 3, and you have got 2xt is equals to 7, they said they want us to find the derivative in terms of y. Okay, let's start by looking at this. We've got two equations here, which is 4x squared minus 3. Then we've got another equation here, which is 2x plus 2xt is equals to that. So now we have got 1 here, then we have got equation number 2 here. So we can use equation number 2 to find equation 3, so that we are able to solve this. So what I will do, I will take equation 2 and then solve for x rather. So what you have here, you have got xt is equals to 7. So divide everything by 2x. Cancel out. Therefore, no. I'm doing it wrong, guys. Sorry about that. Sorry about that, guys. This is 2x. So now what we can do here, we can make x subtracted the formula so that we can put this x here. So we are going to have to divide by 2t. Okay, divide by 2t. So t and t and t and 2 would cancel out. We are left with x is equals to 7 all over 2t. Right. So now this would be equation number 3. Then what we can do, we can sub this number 3 into equation number 1. Okay, before we can even think of taking the derivative. So what would you have? You would say y it's equals to 4, and then what do you have there? Where there's a space of x, we're gonna put 2t all squared minus 3. Therefore we need to simplify this further. Okay, what we can do here in this case, we can come and say y it's equals to 4, and then 7 squared is equals to what? 49. 7 squared is going to give us 49. 49 all over 4 squared, okay, minus 3. Okay, so now what do we do now in this case? You can see 4 and 4 would cancel out. We're going to be left with y is what? 49 t minus 2 minus 3. Therefore now we've got our equation in terms of linear format. Therefore we can come here and say, okay, dy over dt. Why are we saying dt? Because there is no x there. In the space of x we got a t. So dy over dt will be equal to, you're going to drop this, 49 times negative 2t to the minus 2 minus 3, and then this one will just be 0 because now we have got 3 there alone. So derivative of a 3 is going to be a 0. So I don't have space here, so I'm just gonna plug it here. Then we know that dy over dt will therefore be equal to, is going to be equal to negative 98 t to the power of minus 3. Okay, t to the power of minus 3. Yes, guys, and that's how you would deal with questions of derivation. Sometimes they make them like this one here of number 3, but nothing hectic, guys. Don't panic, just follow the basics. I am Gaston Mapala. Let me see you on the next video where we'll be doing more questions on differential of equations.